Good morning to all of you. Today we are going to discuss about these topics, that is error analysis and the different type of errors as well. This subject has been introduced in the GTU, ME, WRE and in the semester number 1. The name of the subject is NMCE, that is numerical methods in the civil engineering. What are the different types of numerical methods? All those type of the numerical methods we are going to discuss. So as of now, and first of all, we are going to study this chapter number 1, that is what we can say as the error analysis and the different type of errors whatever being are there. So we are going to discuss in detail about the error types, the different numerical methods. So basically the subject of numerical methods in civil engineering, that is NMCE, has been divided into total 8 chapters. So there will be 8 chapters and we are going to start from the chapter number 1, that is errors and error analysis. So we are going to discuss about the different type of errors, different type of analysis which are used for the errors. We are going to discuss about that. The error analysis is very important topic as far as the scientific study is concerned, as far as the research is concerned, as far as the computation is concerned, as far as the experimentation is concerned. So the error is important in all those type of the domains. So in the computational research, error has its own role and we are going to discuss about it in the detail. So first of all, let us try to understand what is a error. So error may be defined as the deviation of, what we can say is the error is deviation, means the difference between the two things. That is, one is the measured value, that is you are going to measure something, and the true value, what is the expected standard value. So it is one type of difference. So here we are going to think about the two terms. One is the measured value, we will refer it as, for example, AM, and the true value we will refer about it as AT. So the error, the small e, will be equal to AM minus AT in the mode. Why this mode is used, I will tell you at the later stage. So error is defined as the difference or the deviation between the measured value and the true value, that you need to understand. So this is one of the important definition of the error, that it is actually the deviation or the difference between the measured value and the true value. So we would like to understand about the errors, and meanwhile we must be well aware about the error. So what is the true value? True value, that is the, what we can say is the standard value, any standard value, or what we can say any theoretical value or any expected value, whatever you are expecting any type of answer, so that will be the true value, that can be referred to as the true value. Now what is the measured value? Measured value is actually, what we can say is, after experimentation, if you are getting anything, so it is experimented value or any kind as the observed value, so that is, we call it as a measured value. So this is AT and this is AM, and the difference of these two, AM minus AT, is what we call it as a error. So error is very much useful to study in the subject of computations, in the subject of statistics, in the subject of research, in the subject of computations, and in also various other subjects as well. So this is the very fundamental concept, that we must be well aware about these two terms. We must understand the difference between these two terms, that is what we call it as a true value and what we call it as a measured value. So first of all, it is very much essential to understand the difference between these two values. Sometimes there is a confusion that if we are having a measured value and if we are having a true value. So error is a difference between the measured value versus minus true value, or error is a difference between the true value minus the measured value. So let me tell you that whether it is a difference between measured value or true value, or it is a difference between the true value or the measured value, it will be called as an error. And its value is important, its magnitude is actually important. That's why the error has been written in this form. Always am minus t in the mod. Means the value is considered. For example, if somewhere the am means, what we can say is am is 1.2 and at is 1.3. So if we will do am minus at, then it will be what we can say is minus 0.1, and at minus am will be plus 0.1. But if we will do mod of am minus at, it will give you the 0.1. So the value and its magnitude is actually important. That is first and foremost very much important thing. So this is the thing that you must be well aware about. So that is the thing. If we are considering as of standard in this subject, we are going to use the error as am minus at in the mod. So that you must have to remember. Of course, if am is greater than at, the error will be in the positive. So if you have to apply the correction, then it will have to be in the negative. Of course, it will be vice versa. And if at is greater than am, so then error will be the negative and the correction factor will be the positive. So that is one of the important thing that also we must go across. So these are the two things that we need to understand at the very basic level. So as far as what we have understood, we have understood about what is error. So error, in the error, these are the two things that we have gone through, am and at. We have also tried to discuss about what is true value or the standard value, what is the measured value. These things we have gone through it. So these are the things we have notified till now. So these are the things that you must be well aware about. So now we will try to proceed the fundamentals of the error in detail. So sometimes we used to come across one word. You also come across such type of the word, that is hypothesis. What do we mean by the hypothesis? So hypothesis is what we can say is any kind of study or any kind of solution so that we are going to obtain. So it is one type of the proposed solution of a problem. Any problem is there and it is one type of the proposed solution. Also it is referred to be as assumption yet to be proved. Means there is one assumption that you need to prove by yourself. So hypothesis means any proposed solution of a problem. For example, if problem is there and you are identifying or you are giving some solutions to it, but scientific study remains. So that is the proposed solution. It is one type of the proposed solution of any existing or non-existing problem. Or we can say it is one type of the assumption that we need to prove. So that is the hypothesis. So the error analysis is also as much as important in the hypothesis learning as well. So these are the two things in the experimentation, because whatever be the topics in your research or what we can say is in the dissertation, if you are going to do, so you need to calculate the error or the analysis, some experiments you have to do. So on those experiments or the analysis, whatever you are having, some sets of data, you will analyze that set of data. So it is very much important to understand about the errors and its types. So now we will proceed towards the types of error. So we will try to understand about the types of error. So what are the different types of error? What are the different types of error? So basically there are two categories of dividing the error. First is with respect to time. that is with respect to time we are categorizing it, and second is with respect to the characteristics or with respect to the attribute we are characterizing it. So it is actually important. With respect to time, of course, we know the two categories are, one is the static and the other one is the dynamic. Means if with respect to time it is constant, it is static, and with respect to time if it is changing, then dynamic error is there. But with respect to attribute, there are three kinds of error and those are most important. So first is actually the absolute error. The second one is the relative error, and the third one is also there, that is percentage limiting error. So third one is the percentage limiting error. So these are the three kinds of error. What is absolute error? We must understand. So absolute error is actually the difference between the measured value and the true value. So the difference between two values is actually absolute error. Absolute means how much is the difference between whatever the measured values are there and whatever minus whatever is the true values or the standard values are there. So absolute error is actually difference between the measured value and the true value. Then comes the relative error. So relative error is the difference between these two divided by the standard value or the true value. So relative error. Relative means with there must be some relation. So the relation of the true value will be counted. So AM minus AT, or we can say the absolute error divided by the AT. That also we can do. So that is the absolute error, that is EA. A is actually the difference between these two values. Relative error means dividing just by the true value. Now comes the percentage limiting error. So percentage limiting error is, that is AA minus AT that we have find out divided by AT multiplied by the 100 in percentage. So that is actually the percentage limiting error, and it is the variable error and it indicates the accuracy. So these are the different types of errors. The two classification with respect to time, with respect to attribute, that is characteristics, we have already gone through. So these are the types of error you must be well aware about of. Now there is one most important thing that we are going to discuss, these two terms, that is what is the difference between the accuracy and the precision. So these are two terms that we will discuss. Accuracy is actually the degree of closeness of measured value to the true value. So it is degree of closeness of measured value, whatever we are measuring or experimenting, and the true value. Means how much we are differing with the true value. So for example, if the true value is for example 13.55 meter and whatever we are measuring or we are observing, that is 13.53 meter. So the difference of it is, means degree of closeness will be considered, how much we are close to the results. In the accuracy, one trial is going to happen, or two trial is going to happen, or three trial is going to happen. It depends upon the user, it depends upon the person who is using it. So we need to just calculate the closeness, means how much it is close to the true value, how much it is close to the standard value. Then comes the precision. Precision refers to the repeatedness. So precision is actually the association of the repeatedness and revisions of values. What is precision? For example, if you are having a particular value over here, the almost accuracy is this, and you are attempting the three attempts, 1, 2 and 3. These are the three attempts going to be over there. So for example, this is 1, this is 2 and this is 3, and the average of 3 you are going to calculate divided by the 3. So some value you will obtain over here. So precision is actually associated with the repeatedness, means how close these three values are going to be combined with you. For example, in the experiments of fluid mechanics or in other experimented subjects, you used to take 3 to 4 readings. Means number of readings if you will take, you will go towards the precise result. But if you are going for the degree of closeness, then you are going for the accuracy. So these are the three things. Means accuracy, precision. Accuracy means the degree of closeness, and precision means repeatedness. Means 3 to 4 values you are going to take. So that is very much important. So we have discussed about, as per the attribute classification of the errors, we are having the absolute error, we are also having the relative error, and we are having what we can say is the percentage limiting error. So these are the three classification of the errors. The absolute error is being written is in such a way. The relative error, that is ER, the AM minus AT divided by the AT, because it is calculated with reference to the T, and the percentage limiting error is calculated as AM minus AT divided by AT multiplied by the 100%. So you can see that in such a way these kind of errors are being classified. Now we are going to move one step forward, that is errors and the approximations. How the error and approximation is used to be calculated, and it is useful because now we are entering into the era of partial differentiation or the differentiation. So that we need to calculate, and that we also need to do some exercises. So now we are coming into errors and approximations. So error and approximations that we are going to study. For example, let y be a function of x. This is the equation number 1. We already know that in the what we can say is polynomials, in such type of studies we used to have such type of function that, for example, y is a function of x. Already we know that if x changes from x plus del x is actually a small change in the x, then of course y will change to the y plus del y. So here the first equation was y is a function of x, that is equation number 1. If we will change something in x, if x will be changed, then of course here the y will be changed somehow, because any small change in the x will let this y change. So this is the equation number of y. Now the equation 2 minus equation 3, equation 2 minus equation 1, if we will do, so that will be y plus del y minus y is going to be function of x plus del x minus the function of x actually. So that will come, so y will be cancelled out, and del y is equal to function of x plus del x and then fx. So it will come like that. We can write it as, or we can also write it as in some different way. Means if we want to write it as in such a way, then we can also write is equal to del y. It is similar. So this is the equation number 3. So particularly this equation number 3, I think it is not visible to you, but you can see up to here the del y. I will write it at the top actually. I will write at the top that this equation means del y is going to be the function of x plus del x minus the function of x, or the function of x plus del x minus fx is equal to del y. Both are the same, just written in different way. So this is the equation number 3. So as of now we are having as an whole the 3 equations are there that you can see. So the first equation is y is the function of x. The second equation is any change in the x will let the change in y. There, if addition of del x in the x will also increase del y in the y. So this is the equation 1, this is the equation 2. When 2 will be subtracted by 1, we will obtain the equation number 3. And this is actually the equation number 3. So I think at this point of time you are very you are able to see such type of things. So now we know that if we would like to do the dy by dx over here, so dy by dx is equal to limiting x tends to 0, the function of x plus del x minus fx divided by dx. So in such a way you can write it as, and it can be written as the f dash of x, means the differentiation. So for the differentiation, this kind of function f dash x is used to be written in the mathematics. So that is the thing we must be able to understand. And then this x plus del x minus fx is of course there, that is dy, divided by the dx, that is del x, it can be written here, and it is equal to the f dash, means the differentiation of the fx plus e is some error introduced in it. So here it is x plus del x minus fx divided by the del x. We are going to cross multiply it, the f dash x plus e into x. So we are going to cross multiply the del x on the right hand side. So here the next equation which is going to be obtained, just I am going to write. So this function of x plus del x minus the fx is equal to f dash x plus f dash x into del x. Here the del x is there, so f dash x plus e into del x. So in such a way it can be written. So we can see, and we know that this can be written as, how we can write it as, if this complete thing can be written as the del x. Alright, del y, sorry. So this can be written as the del y. As far as you can refer equation number 2. So this whole equation can be written as the del y is equal to f dash x into del x plus e into del x. So this is actually very small. So we can neglect this particular thing, and we are going to obtain the del y is equal to differentiation of x into del x. So this thing we are going to obtain the equation number 4th. This is the equation number 4th. So in such a way, now as of now we have obtained equation 1, 2, 3, 4. So as a summary, I am going to write all the equations on the single set, and that you can see easily. So the first equation is, what we can say is, y is a function of x. That is first. Second is, any change in x will let the change in y, of course we know. So that is equation 2. Then the third equation, whatever we have obtained is del y is equal to fx plus del x minus fx. That is the equation number 3. So these are the 3 equations. So after referring the third equation, we can do the necessary changes in the equations. So that is the thing. Then del y was there is equal to f dash x into del x. So that is the equation number 4 that we have recently obtained. The del y is equal to f dash x into del x. Now just divide this equation 4 by y. So we are obtaining del y by y is equal to f dash x upon y into del x. So this thing is obtained, and in place of y we can write the fx. So what will be written? So del y by y is equal to f dash x divided by fx into del x. So this is what we can say is the equation number 5. So these 5 equations of the error approximation is very much important, and we all must know the derivation of this that I have shown to you. So in such a way, the equation 1, equation 2, 3, 4 and 5 that can be written. So that is one of the most important thing that we must be well aware about. Now there is just a quick revision of the things. That is what we can say is the type of error. For example, the type of error is, here it is absolute error, here it is the relative error, and if here it is the percentage limiting error. So these are the 3 errors over here that we know. So absolute error, we know the answer in the mathematical form, simple mathematical expression, we know the answer, that is 80 and AM minus 80 divided by 80 into 100. So with reference to the x, what it will be? It will be del x by x and del x by x into 100. And with reference to the y, what it will be? So in the y, in x it will be del x by x and this value, and in y del y, then del y by y and del y by y into 100. So if it is asked that what is the relative error in with respect to y, so we need to calculate this. So this is actually the type of error. So now if this has been calculated based on the y is a function of the x. Now let me write once again. If y is a function of x, means y is a function of x, it was written. But for example, if it is written as the z is a function of x and y. So y is a function of x, means only x and y, two variables are there. But now if three variables x, y and z, three variables are there. So what we will do? So z is a function of x and y. So what we will do? So we will have the del z is equal to, so del z will be equal to del z by del x into del x plus del z by del y into del y. In such a way we need to calculate the del z. Alright, so in such a way, if three variables will be there, so it is for two variables and three variables also we can classify it. So in such a way we need to calculate. So this is the introduction of the error and approximation and how this particular thing has been entered, that we have seen. So stability of any particular system, there is also one of the topic, that is stability. What do we understand by this stability? Stability is a solution is stable. Any solution is stable if it remains bounded despite truncation and the round off errors. Sometimes there are two errors are also being there, that is the truncation errors and the rounded off error. So truncation error is always there when there is a series. So that is what we call to be as a truncation error. That is it is the discrepancy between the true answers. If we are having a series, if first iteration has done second iteration, third iteration, fourth iteration, and truncation means some error has been joined in that. So that is error in a series approximation, that is known as the truncation error. Round off error is after the decimal, how much points we are rounding it off. So that is the round off error. So these are the three things being used in this such type of the computations. As of now, what are the learnings? These three learnings we must be well aware about of. And the fourth one, the important thing. The first is what is the error? Alright, what is the true value? What is the measured value? That we must be able to understand. Then the types of error, that is absolute error, relative error and the percentage limiting error. This is the second learning. And the third thing that we have also gone through is the error and approximation. Error and approximations. And then the derivation of it, that is del y, del x. So this is actually the absolute error in x and y, and if we will do it, then it will become the relative error, and del y by y is the relative error in the y. So as of now, the error and analysis, this is all set for the today. You can refer the tutorial number 1. The tutorial 1 that is already allotted to you. So just start writing the tutorial number 1. You can refer the lecture notes as well along with this video. Alright. So thank you very much and start doing the tutorial number 1. Thank you.